So I'd like to express my sincere gratitude to our respected sir, Ramesh Town, for providing me with this wonderful opportunity, and also helping me with some materials for my presentation. So the topics to be discussed here are architectural design decisions, system organization, modular decomposition styles, and control styles. So before we begin our presentation, I would like to ask you a question. What is architecture? Can anyone tell me? Should I point someone out or will the eligible candidate speak for himself? So I know what is architecture. Right? So exactly. In simple words, architecture is just a blueprint. So what are we going to design? What are we going to develop? What are we going to build? This blueprint is known as architecture. So having said that, since we're computer science students, architecture is not just a creative thing, right? Creating something is art, sure, but if we encompass creation, art,
Sorry,
encompass both art and science together, then we get architecture. So we cannot just think about creating something in brain. We need to check whether that is feasible or not. We need to check whether that is scientifically correct or not. We also need to talk about specification and requirements. So, just creating something isn't merely an architecture. And then we are talking about system organization. So, an appropriate example of this would be, for example, I'm going to build something. Let's say it's a robot, right? But if I don't know what I'm going to build, if I don't know my purpose, and if I don't have a blueprint, okay, so what components will the robot have, or what is it going to be used at, alright? If you don't know the purpose, then we don't know what kind of structures we need. First of all, we design, and then we collect or assemble the structural components, that is known as organization. So we are talking about system organization. A system is a functional body, isn't it? So before making a functional body, we need a blueprint. So that is architectural design. And we are talking here about architectural design decisions. So how are we going to decide what our architectural design will be? Okay? What sorts of questions do we need to bear in our mind before designing something? That is our first step. And then we organize required components. We talk about the relationship between components. For example, if I'm making a house, the house consists of windows, right? Pillars, frames. We talk about RCC, reinforced concrete cement, right? Even though the components are feasible and available in the market, if you don't know how to use them, if you don't know how to assemble them, then our design will fail, isn't it? And if you don't know what are we going to build, what will we do with that raw material? Suppose I'm collecting RCC cement, I'm collecting rods, but I don't know what I'm going to build. So that's all in vain. So architectural design ensures that what we are going to build will not go in vain. And there comes modular decomposition styles. So when we're talking about system, a system can have various functions, and some functions are independent. For example, if I'm logging out of Facebook, does it really ask some questions, redundant questions like, why are you logging out? Is there any problem with me? Is that asked? I'm asking you, is that asked?
Are you sure you want to log out?
Sometimes that's asked, right? But that depends on site. It is mostly asked when we report something, like when we report a page. So what went wrong there? Sensitive topic or something graphical? But when we're logging out, it doesn't ask like that, because that is an independent function. When we're logging out, what we are doing is we are just logging out of the system. We are not doing anything else, right? So certain independent modules, independent systems are present in our software. So we talk about modular decomposition styles in there. And then we talk about control styles. So since we're in software engineering, we talk about certain constraints. Like we cannot just go and make whatever we like, alright? Like we might make that, but it won't be legal. And like for example, head of the department controls our department, right? So in similar way, server also decides what it should give to the client. So who is in authority? Who is the master and who is the slave? These are basic terminologies. Who is the master and who is the slave? That's it. So who is the master and who is the slave? When we're talking about master and slave, we're talking about constraints. We're talking about limitations. Okay? How do we control our designs? So that we discuss in control studies. So initial queries. What your architecture? Sorry, this should be what is architecture. What is architectural designing and what is organization? Any queries on this? Any queries, Yamzu? Are you clear what is organization? Okay, so let's go to architectural design. Architectural design in software engineering is about decomposing the system into interacting components. Like I said earlier, certain components are independent. So how do they interact within the system? That is understood by decomposing it, defining an overview of the system structure, features of the component. Yes. What features do the components possess? And the overview of the system structure. That is also discussed under architectural design. And how these components communicate with each other to say shared data. Okay? Sometimes the components themselves might send data, or sometimes they might come to the main authority and then exchange data from there. So we'll talk about that in other modules. So let's talk about system properties of architectural design. So the first one is security. These are kind of similar to non-functional requirements that we discussed in previous presentations. So security. Architectural design uses a layered architecture with critical assets in the innermost layer. So whatever assets are there in the innermost layer, they are meant to be critical. So what do you mean by critical assets? Anyone? Robin? Gambhir. Okay. Gambhir in what sense? We have studied object-oriented programming, right? In there we talk about public data, private, protected, isn't it? So the ones that are needed to be kept secured, like the private and protected data, they should be in the innermost layer. We will talk about this in tiers, okay? Multi-tiers. So the critical assets, like I talked about, that will be in the innermost layers, while the ones that are not that critical, the presentable layers. For example, when we go to search engine and Google something, we are not necessarily presented with the application part, application server, we are only presented what we want to be presented. For example, if I am searching, is Apple good for health? Then the exact results will be shown there, but the database, that will not be shown there, right? So that is what I am talking about. कसरी भइरहेछ भन्ने कुरालाई चाहिँ राखेको हुन्छ के देखाउनु पर्ने के प्रेजेन्ट गर्नु पर्ने भन्ने कुरा बाहिर हुन्छ एन्ड परफर्मेन्स सो सिस्टम प्रपर्टिज अफ आर्टिफिशियल डिजाइन परफर्मेन्स mean time taken between request and response of the page is known as performance between the request and the response of the page. So these are the things that will be ensured if there is proper architectural design. And how can performance be improved? Performance can be improved by avoiding critical operations and reducing communication between components. I don't know how that is. So if the components themselves interact, more than it is required, then the performance will be slow. So that is what should be avoided. And that is ensured by architectural design. And maintainability, easily modifiable and replaceable components. So if components are easily modifiable and replaceable, then our software can be evolved in long run, right? अहिले जे चाहिन्छ त्यो अहिलेलाई राख्ने पछिको लागि के चाहिन्छ त्यो कम्पोनेन्ट्सहरु आफै इभल्भ हुने मोडिफाइबल भयो भने त It's easier, right? So like I said earlier, we need to ask ourselves what are we going to design. So there are certain decisions, certain questions that we need to ask before deciding what architectural design are we going to make. The first one is, how will the system be distributed across a number of cores, processors, that means network. So how will the system be distributed? Who will be the authority? How will the components interact? What approach will we use to structure the system? There are various approaches, scientific approaches. So like I said, it is not just in vain, it is not just a creative process, it is a scientific process. Which architectural styles are appropriate, right? Which architectural styles are appropriate and usable, reusable, alright? And how can software architecture be documented? Documentation is very important. Can anyone tell me what is documentation? No? It's like, what is a document? Okay, tell me what is it. Devans.
फाइल डान्स सबै कुराको लिस्टहरू लेखेको हुन्छ प्रोग्राम डकुमेन्टेसन भनेको सफ्टवेयरको सबै ब्याकग्राउन्डहरू
Exactly. So document consists of official information, and in this case, we are talking about architectural and design decisions, right? So how can software architecture be documented? Software architecture is basically the end product of architectural design process. We have a process, and the end product is software architecture. We make certain prototypes, but we need to enlist what does the prototype do. If we want to make our clients, our customers understand what we are going to make, we make SRS documents, right? So this is also similar to that. How can a system be decomposed into modules? Like I said, independent parts. And what control strategy must be used to control the operation of the components in the system? How can the components be operated, right? Whether they work independently or whether they are controlled by something. And the next one is, what architectural organization is best for delivering non-functional requirements of the system? When we are talking about architecture, we are talking about functionalities. But here we can see we are talking about non-functional requirements as well. Because functional and non-functional requirements, they work hand in hand. Alright? If certain functions are ensured in a software, then non-functional requirements such as security, maintainability will also be easily ensured. So that is also something that needs to be kept in mind. So what comes into play once we have talked about organization? Anyone? Everyone being silent. Okay. First of all, there is functionality, right? That means architecture. So this simply means I'm talking about structure. Once we have talked about designing, we go to structure. So hence, we have come to this slide, system organization. What does organization mean in literal words in terms of software development? Robin, what does organization mean in literal words? Software development को क्षेत्रमा चाहिँ अर्गनाइजेसनलाई कसरी बुझिन्छ सामान्य भाषामा? अर्गनाइज गर्नु भनेको चाहिँ के हो? म्यानेज गर्नु हैन, स्ट्रक्चरहरू कलेक्ट गर्नु, एसेम्बल गर्नु हैन. So what do we study here? We talk about structural relationship. And we talk about implementation of architectural design. Yes, organization is basically the implementation aspect of architectural design. It is not that different from architectural design. And the relationship between components. First of all, there is structural components, and then there is relationship between independent components. Like झ्यालको एउटा रड चाहिँ independent हो नि त. केही बनाएपछि न त्यसले केही दिने हुन्छ relationship हैन. Realizing architectural specifications. So whatever architectural specifications we have, if we realize them, if we concretize them, like we're designing something, and then we print it in 3D monitor and then we showcase them, that is realization, right? We design a blueprint and then we make it in real life, that means realization. So now we have come to software architectural models. So static type of architectural structure model represents the major system component. So when we're talking about static type, we're talking about major system components. And the dynamic type represents process of the system. First of all, static type represents system components, structure of the system. This is focused on the component, the static one, whereas the dynamic one is focused on process. And the distribution type of architectural model represents how the component is distributed across various computers. It talks about distribution, how is it distributed, correct? And when we're talking about distribution, we're also talking about paths, connectors. That is the actual technical term for this. We will talk about that in other slides. And then the fourth one is interface type of architectural model. So when we're talking about interfacing, we are studying interfacing in 8255, 8085, right? We also did the practical. You guys remember? No? That's the RAM room or interfacing one, but I think fourth semester, no? User interface, GUI, graphical user interface, that I think that is familiar to us. Is it, Susan? Why do you think this interface needed? Why do you think this interface needed? Simple, to share data, right? It's not interface type of architectural model represents the interface of the components exchange information. Relationships type of architectural model represent models such as data flow diagram to represent the component relationship, interrelationship. The last one. It represents models such as data flow diagram to represent the component relationship. So we have studied about data flow diagram in previous presentations. And once our design process is good, then what does Chandler have to say about this? Could this design process be more perfect? Right? So to document the architectural design process, architectural models are used. So that is a summary of my previous slide. So architectural design models are application domain specific, and the most common two types of domain specific models are generic model and reference model. So let's go through generic models. Abstractions derived from a number of real systems and encapsulated the characteristics of these systems. So a number of systems, real systems are derived from, abstractions are derived from a number of real systems, and they are enveloped. And this follows bottom-up approach, whereas the reference model are derived from the application domain rather than from existing systems. These are derived from systems, whereas these are derived from domain. And this follows top-down approach. And this also provides a comparison between different software architecture. So now let's go to architectural styles. The first one is data flow architecture. Now this is an important part. Here we talk about components, right? So these rectangles, let's say, these are filters. So filters means components. And the connection between them, the connectivities, the connectors, are known as pipes. The different architectural styles have different terms, so you need to keep that in mind and you can take notes. So the components are known as filters in data flow architecture, whereas the connectors are known as pipes. So filters transform the data and send this to other filters using connectors. So filters transform the data, send this to other filters using pipes. Pipe is a unidirectional channel. Okay, this is also very important. Unidirectional, it doesn't come back. Okay? Like it is not bidirectional, it is just unidirectional. And each filter works as an independent entity. So solo karu, like you filter, kina esto kaam garyo, kina esto kaam garisanu sodhiदैन. यसले आफ्नो डाटा गुड पे गर्छ, यसलाई पठाउँछ, र इन्डिपेन्डेन्टली वर्क गरिरहेको हैन? कनेक्टर छ, कनेक्सन छ, तर युनिडिरेक्सनल फ्लो छ. सो यसलाई पठाइसकेपछि यसले किन पठाएको भन्ने चाहिँ हो. So as we go through these architectural styles, we are just in number 1, but as we go through other points, we will also find that these architectural styles have been evolved. Evolution, we know evolution, right? So human beings also evolved on, right? Our heart has 4 chambers, we can adapt to any kind of environment, right? So this thing usually they adapt to the hyposign. This is kind of rigid. We talk about this term, rigid. Alright? So what is rigid? Rigid means not flexible. So this is not very flexible. So you can see this model here. Like I said, there is unidirectional flow. There is unidirectional flow, right? From here to here. See, there is unidirectional flow. याबाट यहाँ आएपछि फेरि यताबाट त्यतै पुग्छ unidirectional flow छ नि त हैन एउटा कनेक्टर एउटा पाइपको मात्र कुरा गरेको के स्ट्रक्चरको भन्दा पनि let's talk about the aspects. And while talking about the aspects, there are positive as well as negative aspects. So the positive aspects are it's supposed to reusability. It is maintainable and modifiable. Okay, it is rigid, but it is however maintainable and modifiable. And it supports concurrent execution. What do you mean by concurrent? Concurrent in Nepali में तत्कालीन भनिन्छ नि. So existing execution let's say support does it. And some disadvantages are it often degenerates the batch sequential system. So since we know this is a sequential system as it is unidirectional, but then there will be degeneration. It does not provide enough support for application required and user interaction. So is there user interaction here? Unidirectional bypass interaction, but the interaction goes 2 ways, right? Or multiple ways. But it is only unidirectional, so it hinders user interaction. And it is difficult to synchronize 2 different but related streams. So as we can see, these streams are different, but if they are related, the synchronization is not very possible because this goes in this direction and in this direction. एक आपस में exchange बात ज़्यादा कहीं चलने नहीं. Now the next one is object-oriented architecture. So when we talk about object-oriented, we are talking about real-world objects. We have studied that in object-oriented programming as well. So the components are represented as objects. In the previous slide, in the previous data flow architecture diagram, what we saw is the components were called filters, right? But here the components are called objects. It's very easy. And then the way they interact with each other, the paths, that's known as methods. Objects interact with each other through methods. Methods are connectors. Objects are the connect governance method. Objects maintain the integrity of the system. An object is not aware of the representation of other objects. So these last 2 points are similar. They maintain the integrity. An object has its own function. The other object has its own function, even though they are connected. So since they have independent function, they maintain the integrity of the system. So the advantages of this are allows designers to decompose a problem into a collection of independent objects. Like I said, integrity. A problem is decomposed into a collection of independent objects. These are independent objects. So this is how problems are decomposed. You can also understand this as modules. Alright? Objects interact with each other. Implementation detail of objects is hidden. कसरी इम्प्लिमेन्ट हुन्छ भन्ने कुरा चाहिँ एकजना भिडियो हुन्छ फ्रम इच अदर है त एक आपसमा अर्कोलाई थाहा हुँदैन कि यो अब्जेक्टले कसरी इम्प्लिमेन्ट गरिन्छ भनेर अर्कोलाई थाहा हुँदैन. And hence that can be changed without affecting other objects. So this object I'm sorry for the distraction. So they can be changed without affecting other objects. If I want to change this object, I can change it without affecting this object. So this is very important. 3 layered architecture. So layers. I said this in the very beginning that the critical assets are kept in the innermost layer, right? So that is the same thing here. We hide the critical aspects in the innermost layer, and the presentable aspects are on the outside layer. And here, layers are known as components. In the first one, filters were known as components. In the second one, Objects were known as components, and in this layered architecture, layers are known as components. And layers are arranged in hierarchical manner, each one built upon one below it. Alright? So there are layers. This is presentable layer, this is application layer, and this is database layer. This is the critical aspect. So this is critical aspect. No, not aspect, asset. Or even aspect. And this is presentation. Presentation layer. So when we open our browser, this is what we see. We don't see this database server, for example. We don't see database server. We only see client, we are clients, right? So this is what is presentable to us. This is hidden. So layers are components. These are components. And the connectors are protocols. I mean, what is protocol? What is connected in the first architectural model? Data flow.
Pipes.
Pipes. Yes, pipes. And the second?
Methods.
Methods. And here? Protocols. Protocols are connectors. The interaction between layers is provided through protocols. So how do the layers interact? That is provided by protocols. Presentation layer, business layer, processing layer. These are collectively known as application layer or logical layer as well. Alright? So synonyms also. What is logical layer? And application layer. So application is logical layer. So these come under application layer. You error they have separate critical asset. Also known as n-tiered architecture. And here are the 4 other tiers, 1, 2, 3, 4. So this is also known as n-tiered architecture because we can have multiple tiers. Some are closed. The previous layer cannot bypass a layer with a closed layer. Protocol so this is closed one. So the previous layer can bypass the layer with the open layer. Open layer bypass this is open layered architecture. And this is what we call tiered architecture as well. And tiered. Specifically, n 1, 2, 3, 4 it is tiered tiers and the next one is data center architecture. So when we say data center, what comes in our mind is data is the primary component of this. Alright? Data line 1, 2, 3. Data is of primary importance. A central data structure in the data storage is there. That is known as central repository. In exam, we will be asked what is central repository model. It represents the current state of the data. A collection of client software is there. What I am talking about is there is a repository, storage, let's call it rep, and then there are clients. Alright? 1, 2, 3. Client software performs several operations like add, delete, update, etc. on the data store. So here data store becomes a repository. This is operational. It's clients person. What is the main important primary importance को क्या भयो त यहाँ clients important हो त यहाँ अनि डाटा नै important हो त किनकि operations गरिएको छ डाटामा डाटा सेन्ट्रिक भएर गइरहेछ यो आर्किटेक्चर. So यसको एडभान्टेजेस चाहिँ clients operate independently of one another. So clients लाई यो सम्म मात्र सरकार भयो स्टोरेज सम्म. अब क्लाइन्टले के गर्दैछ सँग सरकार भयो. Data repository is independent of the client. यो पनि client सँग independent छ. आफूसँग जे डाटा छ क्लाइन्टले के अपरेसन गर्छ सँग भयो. It adds scalability. This is new clients can be added easily. So since this is a repository, new clients can be added easily. And it doesn't depend on how many clients are there. It's supposed modifiability. Sure, one client can be reduced or added, so it is modifiable. And it achieves data integration in component-based development using Blackboard. So there is data integration as well. Client 1 does one operation, client 2 does another, client 3 does another. There is integration of data. So this is an example. There is two interaction as well. Pipeline versus scenario. So we will give filter pipes versus relation scenario. So this component, these are components. Components के बारे में सारे क्या है? Right? Clients. 100% है So your stories back, let's say, registration, your function month on the client reports, approvals, administrator, course figure, you know, clients, let's say, administrator or administration to things, process. So let's say repository is some other solid and yes, there is some functions are sorry. So this is also very important. Core and return architecture. It enables software designers to achieve a program structure which can be easily modified. Function is decomposed into a control hierarchy. Sequence. Inheritance also the insect side. So that is what we understand by hierarchy. Control hierarchy. Main program is divided into routines and subroutines. So this inherits from this and this inherits from this. So these two inherit from this. Function is decomposed. This is decomposition, right? Breakage. It's decomposed into a control hierarchy where the main program invokes a number of program components. These are the number of program components which in turn may invoke other components. So this invoked this and this in turn invoked this. Right? Remote procedural call architecture is an example of this. In this, components of the main or subprogram architecture are distributed over a network over multiple computers. You thought multiple variables, right? Remote procedural call architecture. This is call of main program of the data variable. Let's say I come from Ilam and Ilam Kathmandu distance, Kathmandu Chittagong distance ma kun nazik cha to Chittagong nazik chain हैन म रिमोट एरियाबाट भयो सो त्यसलाई चाहिँ रिमोट प्रोसिजर कल आर्किटेक्चर भन्छ Now we come to control styles. Control styles, like I said earlier, is concerned in how a system is decomposed into subsystems. कसरी सिस्टम एज सबसिस्टममा डिवाइड गरिन्छ त यो त मेन प्रोग्राम नै भएन भने त्यही नहुन्छ त एक्जिस्टै गर्दैन नि हैन सो कसरी एउटा सिस्टमलाई चाहिँ सबसिस्टममा डिवाइड गरिन्छ त That's what it is concerned about. Subsystems must be controlled so that their services are delivered to the right place at the right time. So this routine one cannot do its function without getting some instruction from routine one. They should say what this routine 1.1 is supposed to do. Now you can go over routine 1 is 100%. So that is known as controlling. Subsystems must be controlled so that the services are delivered to the right place at the right time. We are talking about place, कहाँ जाने र टाइमको पनि कुरा गरेको छ अघि आर्किटेक्चर डिजाइनले के इन्स्योर गर्छ भनेर हामीले परफर्मेन्स भनेछौँ नि भने चाहिँ हामीले गुगल गर्ने के कुरा अनि आउनु चाहिँ धेरै टाइम लाग्यो भने त्यो भएन नि त सो स्ट्रक्चरल मोडल्स डु नट एन्ड शुड नट इन्क्लुड कन्ट्रोल इन्फर्मेसन सो कन्ट्रोल इन्फर्मेसन चाहिँ इन्क्लुड गरेको हुँदैन स्ट्रक्चरल मोडल्समा सो त्यसले नै गर्दा हामीले कन्ट्रोल स्टाइल चाहिँ नेसेसरी भएको कन्ट्रोल इन्फर्मेसनलाई हाइड गर्ने कन्ट्रोल गरिसकेर हामी रिजल्टमा त त्यहाँ आउँछ नि त होइन कसरी कन्ट्रोल गरिरहेको छ भनेर वी डोन्ट नो So they do not include control information and they should not include control information. So the first control style is general control style is centralized control stack. This is very primitive. There is only one controller and multiple processes are controlled. User interface is controlled, communication processes are controlled, sensor processes are controlled, fault handler is controlled. So let's give you an example of